Hello everyone, thanks for joining today. In this webinar, I'll be walking you through a little bit about managing multiple RF zones. This can be kind of a tricky thing to do, especially if you're working in a large or distributed network or environment. So since you've made your way to this webinar, I'm going to assume that you've already got some experience calculating frequencies for wireless equipment in at least one RF zone, whether you're using Wireless Workbench or some other calculation program. And also because we're focusing on some specific challenges around multiple RF zones, I'm not really going to discuss many other topics or features except as they pertain to calculating for multiple zones. If you'd like more detail, feel free to add some comments into the webinar pane, and we'll try and get to those at the end of the session. So some of the things that we're going to cover today include what are RF zones in Wireless Workbench? How do they work? When do you use them? And how do you create and configure them? So with that, let's get started. So today I'll be walking you through the interface for Wireless Workbench 6, version 6.13, which came out in July. Workbench is a free desktop application that facilitates the management and frequency coordination of wireless systems. And while you have numerous advantages for using Shure systems for your frequency coordination, it's not exclusive to Shure equipment, so it is manufacturer agnostic. And what are zones? Zones are a coordination tool in Wireless Workbench. They represent a distinct RF environment that may or may not overlap with another RF environment. So these could be a room or a floor in a building. They could be a building on a campus, a stage at a festival. It's really any environment where we think that the distance between two places or physical obstructions between them would prevent or reduce the impact of a transmitting frequency on another location. They work by grouping multiple areas or multiple components into an area and using configurable isolation between the groups to get more frequencies in the calculation. When there's enough isolation between the zones, you can reuse those frequencies that Wireless Workbench would otherwise register as interference. So when should you use these? You should consider using zones when frequencies that you're coordinating for Wireless Workbench, you're not getting everything that you need in a single zone, and when you're working in an environment that contains multiple separate spaces. So this is the sort of union of two different attributes of your calculation. Not only are you not getting enough frequencies, but you are working in multiple spaces. So this is something to note here, that RF zones is not just an organizational tool. They change the way that Workbench calculates and analyzes frequencies. So when it's used improperly, such as for organization, it can lead to the perception that you've generated a compatible set of frequencies, when in fact it's not really operational in the real world. So if you're looking for a tool to keep your frequencies and devices organized, you can use tags and colors from the inventory to do that. So another important note before we begin or go much further here, I'd like to point out a very important detail about how Wireless Workbench is set up. And that informs your workflow, or rather your workflow will inform how you go through creating your RF zones. And this depends on what your ultimate objective is. So Wireless Workbench's inventory and frequency coordination tabs are effectively split and don't necessarily contain the same data, except through your explicit action. And this is a choice that we made to meet user requests for more iterative frequency coordination without inadvertently affecting the equipment in your inventory. So why does this matter? Well, when you're some of your coordinating frequencies that you provide, some of you guys are coordinating frequencies that you provide to someone as a report, right? And so you may never be connected to the equipment, while other people are coordinating frequencies specifically for deploying to the inventory or deploying to real equipment. So this distinction is really how we set up zones in the first place. If you're coordinating just for creating a report or a list of frequencies, you can actually create all of your frequency assignments directly in the frequency coordination tab. Whereas if you're trying to deploy to the inventory, it's recommended that you first connect to your network devices or add virtual offline devices to your inventory and then assign them to zones prior to coordinating frequencies in the Frequency Coordination tab. So to add and remove zones, you can go to the Tools bar in the menu bar of your computer and go to Manage Zones, or from the Frequency Coordination tab in the lower left-hand sidebar, there's a little handle that you can pull out to open the drawer that has the Manage Zones and Zones list there. If you go to the menu bar, Manage Zones, and then create any number of zones, that sidebar automatically opens up in the Frequency Coordination tab. So when you open the Zone Manager, you'll have two different tabs that you can work with, and the Configure tab is disabled by default until you create more than one zone. So by default, there's always one zone because you need some space in which to coordinate your frequencies. You can then create as many zones as you like, but that should really be dictated on by how many different spaces you expect to have your various equipment. So once you've created your zones, you can pop over to the Configure tab, and what you'll see here are the different types of relationships that the zones can have, and they're configured in a matrix that shows you the relationships of each one to the next. And there are a couple types of interference that we're concerned with here when we're coordinating for multiple zones. Before I get into what those are, let me talk a little bit about what equipment profiles are. In Wireless Workbench, and really for any wireless system, you have a set of spacing parameters. You can view these in Wireless Workbench by going to the Tools menu and then Equipment Profiles. Basically, the spacing determines the acceptable proximity to another signal. So if we're looking at this center column here for a standard compatibility level of an Axient digital system in the G57 band, we have multiple different spacing parameters. The channel-to-channel spacing basically says how close can my desired frequency be to another signal that's in my spectrum. Each one of the intermodulation spacings is asking the question, or rather presenting the information of how close your desired signal can be to an intermod. The intermods are basically harmonics generated by two or more transmitters in close proximity to one another. So this is going to be relevant when we go to configure zones. This is a visual representation of how those spacing parameters really work. If I've got a single frequency and some arbitrary second frequency that's not depicted here, basically for my desired frequency, I've got a channel-to-channel spacing value as well as a couple represented intermod spacings here. If there's any other frequency that violates one of these, it usually comes up as some sort of incompatibility during a calculation. However, if you're working with frequencies in different zones, you can choose to either respect or ignore these spacing parameters. So going back over to the Zone Manager, we've got a couple types of interference that we're working with, the channel-to-channel and the channel-to-intermod. Channel-to-channel interference is depicted in blue here and a check mark, whereas channel-to-intermod interference is represented by the pink or the magenta rectangle here and the checkbox. So looking at the top, we've got just the channel-to-channel spacing that is respected and not the intermods, and a visual depiction of how you might consider those zones. That's where you have a little bit of overlap between say Zone A and Zone B. And this is pretty typical. You might see this in floors of a building where on one side of the building you don't really have a whole lot of interference or leakage from your transmitting signal getting into the other zone. But in some spaces, they will actually overlap. Now, this is the default setting, and if you've been using Wireless Workbench 6 for a while, this is the setting that you've always had. It's what was presented by default without an option for changing it. Moving down a level, we're looking at both channel-to-channel spacing and intermod spacing being respected. And there are a couple different ways that this could manifest itself. What I've depicted here is a pretty significant overlap of Zone A and Zone B, though it's not entirely overlapped. And what's important is also the context of one of those zones to another zone, like Zone C. In this context, we're expecting that the relationship between Zone A and Zone B is very significant, where my transmitter actually might walk into that space and certainly might produce some intermods. And then lastly, we have our most liberal setting where the zones are unrelated. Now you might see this in two buildings on the opposite end of a large campus or two stages at the end of a large festival. This basically says that neither of the frequencies or the transmitters in either zone are really going to overlap with one another, and nor will they create intermods between one another, either at the transmitter side or the receiver side. So in order to determine for yourself whether you should be using a more liberal setting, a more strict setting, or somewhere in between, there's a good test that you can perform. Ideally, you would put your transmitters and receivers and antennas in the locations that you expect them to be during your event. You could also turn on at least one scanner or receiver in each location, and Shure receivers can be used as scanners in Wireless Workbench. And then turn off all but one transmitter in one of those zones. And with that on, using the frequency plot tool or the frequency plot inside the frequency coordination tab, you can take a scan and view that frequency. Now, the frequency itself is not so important, as is the amplitude of that. So you'll want to note the amplitude of that frequency in those other zones. For peaks that are greater than negative 70 dBm, you might want to consider these to be in the same zone. For peaks that are less than negative 70 dBm, these are related zones. These are the moderate overlap, but not entirely overlapped, where you wouldn't necessarily want to consider the intermods as an interferer. And then lastly, if the peak that you find in one of these scans is less than negative 85 dBm, which is what Wireless Workbench considers your default noise floor, this is where you can consider the zones to be separate from one another. As a general recommendation, to consider zones entirely separate RF environments, you just don't want your transmitter from a given zone reaching another receiver. So if it's under that negative 85, you should be pretty good. You would then repeat this step for every zone. So then you would shut off the transmitter in Zone A, for example, and turn on the transmitter in Zone B, rerun the scan, and repeat the same thing for each one of your zones so that you can determine the relationships between them. So there are also some circumstances where you might find yourself in need of a roaming frequency. This is where you would see a transmitter that could be present in any zone, but not necessarily all zones at once. In order to configure Wireless Workbench for this scenario, you would want to create one zone, say Zone D in this example, and make its relationship to every other zone as stringent as possible, considering both channel-to-channel spacing as well as intermodulation spacing. In this way, Zone A, Zone B, and Zone C would know to stay away from the frequencies that are calculated in Zone D. But this doesn't consider the frequencies in Zone D to be global frequencies, which is to say a frequency that is on at all times. It's really just a frequency that could be in any one of these locations at any time. So with that, I'm happy to jump into a little bit of a demonstration in Wireless Workbench for coordinating one of these systems. So I've got just a blank show that I've opened up here in Wireless Workbench, and the first thing I'm going to do is just bring in a scan file that I've got from the past. I can't quite remember where this is at, but in any case, it will do for us. I'm going to go ahead and set my window of the scan just to the frequencies valid for the United States here, which would be 470 to 608. And that's sort of leaving off the 614 to 616 range, where you can use licensed and unlicensed transmitters at lower transmit powers. But to my earlier point about where you'd like to create your frequencies first, because I'd like to deploy these to some systems, I'm going to jump over to the inventory and add some devices. So I'm just going to add a few at random here. I'm going to add an Axient Digital, and I'll add, let's go with 24 channels of Axient Digital G57. I can make some PSM in the G10 band, and I'll go with 24 channels of that as well. And for yucks, I will also add some ULXD, also in the G50 band. And I'll add 12 of those. So now that I've got this, what I'd want to do is, you'll notice in the inventory, I've got all of these set to the default zone. And this is where you'll see in the Manage Zones Zone Manager dialog that this is our default. But let's work with 3 different zones. I'll call them Zone 1, 2, and 3. Because I don't necessarily know the relationships between them, I'll leave them at the default for right now until I assign them. But of my microphone channels, let's say I want to grab, we'll go with 16 channels of the Axient Digital, and I'll put this in Zone 1. I'll grab my remaining Axient Digital, and I'll put this in Zone 2. I'll take all of my ULXD, I'll put this in Zone 3. Oops, I missed my Zone 2 here. And I'll take half of my PSM, and I'll put this in, well, I don't know, Zone 2, and the other half in Zone 3. So this is entirely at random, but I've now assigned my frequencies to zones, and I need to bring them into the coordination workspace in order to calculate them. So I could do that by going over to the Frequency Coordination tab, and then in the lower right corner there's another tab for adding frequencies. If you are not connected to devices or deploying them or creating virtual devices in the first place, this is where you can request additional frequencies, which basically says, I just want to create frequencies in the frequency coordination workspace by itself. But since I have some in inventory, I'll select my frequencies from inventory and just grab all of them. And what you'll see on the left-hand side is that I've now populated each of my zones. Zone 1, if I collapse all of these, will have my Axient Digital. Zone 2 will have my PSM and Axient Digital, and Zone 3 will have my PSM and ULXD. So I haven't run this coordination before, so we're just going to go ahead and hit calculate and see what happens here. And thankfully, for the purpose of this demo, we've run into an issue. So we've got ULXD who's just not quite getting as many frequencies as we want here. Well, there are a couple ways to handle this. In the spirit of this webinar talking about managing zones, one of the first things you could do is consider what is the relationship of Zone 3 to Zone 1 and Zone 2. Well, if I know that Zone 3 and Zone 1 are far enough away from one another, I could just disconnect them and try running this calculation again. And it turns out in this scenario, that didn't really help out here. So maybe if I let this keep going, I might be able to chug out those next couple of frequencies. But perhaps the relationship between Zone 3 and Zone 2 also needs to be modified. Is it more stringent? Is it less stringent? This is something that's going to be dependent on your own scenario. In this case, I'm just going to go ahead and disconnect it just so we can see what would happen if I do. And we can see that we start getting closer to our desired frequency count. There are some other tools that you can use in addition to just moving frequencies from zone to zone and changing those zone relationships in order to get the frequencies that you need for your calculation, which includes certain things like our compatibility profiles. So you might recall from the Equipment Profiles menu that we've got the filtering and intermod spacing. So if I'm looking at my ULXD system, which is the one that seems to be giving me trouble here, and I go to the G50, what I'll see here is I have 3 different columns for my spacing. The standard one gives me spacing that says for my 2-transmitter third-order harmonic, I've got about 75 kilohertz before of spacing from another frequency. Whereas in more frequencies, it's down to 0, but it leaves my channel-to-channel spacing the same. So one option is to change to more frequencies. Now what this does is it assumes that I have narrower spacing between my frequencies, but it could be just the ticket that I need to get that last little bit. And it seems we've already jumped up to just one frequency away from that. Other things that you have at your disposal include the exclusion threshold, which exists over here in the right sidebar at the top, and also on the frequency plot here. So this is what really guides your tolerance for your noise floor. So you'll remember when I said that the default is -85. So if we left it there, this is our default configuration. But if I wanted to be a little less conservative or more aggressive with my coordination, I could also raise this up above some of the noise that's in here and try running again to see if that helps out. And just like that, we've got some more frequencies. Other things that you could use that are at your disposal, and one thing to point out about the configuration that I've set here for all my frequencies is that all of these are in the 400 and 500 megahertz bands. So my Axient Digital G57, my PSM G10, my ULXD G50, all of these exist somewhere between 470 and 608 megahertz. So they're really kind of crammed on top of one another. Without going into too much detail about the background of the feature, some things that you could do include creating inclusion lists. What inclusion lists do basically lets you set up different groups that you might separate into mics and IEMs, for example. And this is just a general good practice as well for coordinating frequencies in a healthy environment, is that you might want to put certain things in the lower parts of your band and certain things in the upper parts. So I know that my PSM isn't as wideband as my Axient Digital, nor is my ULXD, and so I might want to put those lower in the spectrum and reserve the upper parts of the spectrum for Axient Digital. So if I were to reconfigure this and say this will be ULXD and PSM, and this will be Axient Digital, then I could, for example, say that these two will go from 470 up to the max of whatever PSM's G10 band is, which I believe is 542. And then for my Axient Digital, I could have just a little bit of overlap so that I'm not trying to cram 16 frequencies into a small amount of space. I could say that this goes from 530 to, let's put it at the top of its range, which I believe is 608 in this case. And so, again, I haven't run this, so we'll see if it works. I'm going to reassign these to different inclusion groups. So you can right-click on the header bar of a given profile here in the coordination workspace and move it to an inclusion group. So I'm going to move my Axient Digital. I'll move my PSM. Got this other Axient Digital in Zone 2 as well, which I'll move to AD. And then I'll move PSM and ULXD to its inclusion group. And then I'll cross my fingers that we did this right. So this gets us about the same amount of frequencies that we were seeing before, where it looks like the frequency band overlaps that we've had between our systems is about as optimized as it can be. These are all pretty wideband systems, 64 megahertz in the case of ULXD, 72 megahertz for PSM, and I believe that's 138 for Axient Digital. And just like that, we give it a little bit of time, and now we've got our frequencies. So what this does for us, if I were to hide a little bit of the information that I'm showing in my plot here, such as my frequencies, my primary frequencies and backup frequencies, what you'll notice is that I get this little overlay on the plot. And this is basically showing where my inclusion groups were placed. So that first one, my ULXD and PSM, I've shoved over into this corner of 470 to 542, and then we have our little overlap from 530 up to 608 where my Axient Digital could go. There are other ways that you can use inclusion groups to segment your frequencies, such as putting mics and IEMs on one side or another, moving entire zones to one side or other in the spectrum. And these are just different ways that this application can be flexible and help you coordinate for multiple zones.
Wow, lots of great information. Thanks, Corey. So now it's time for questions. We don't really have very many, so if you've been waiting and sitting on your question, go ahead and please type it in right now. If you don't see the question pane, look for a dark gray toolbar with an orange box with a white arrow on it, and click on that, and that should give you access to the question pane. So far we just have one question, and it's actually a question for me, believe it or not. Question is, will this video be available later for on-demand viewing? And it will be. All of our webinars are available for on-demand viewing. We do record them, and it usually takes us about a week or so to get them processed and edited. But when it's available, it will be available at shure.com/webinar. There's all sorts of great past webinars there as well. So shure.com/webinar. And I was hoping some more questions came in, but it doesn't look like any have. Corey, I guess you were super thorough, and everybody got it.
Excellent. What do I win?
Self-satisfaction.
I'll take it.
For the rest of you, if you do have a question that you were just too shy to type, or something that'll crop into your mind later, or something about an unrelated audio topic, you can always send those to our applications engineers at support@shure.com. We've got a lot of great guys and gals on that team that can answer questions along a wide variety of audio topics. So please feel free to write to them at support@shure.com. We want to thank you so much for joining us today. Late breaking questions. Here we go. What is the latest version of Wireless Workbench right now?
The latest version is Workbench 6.13.0, and you can find that on shure.com/WWB6.
Great. All right. Why do we have issues when we have receivers closer to the LED wall display in an install?
That's a great question. So those LED walls actually emit a significant amount of energy, and it's broadband, so it can really affect and really wreak havoc on some receivers. And it depends on the antennas that you're using, the proximity that you are to those LED walls. But it's really that broadband noise, just how any other single carrier frequency can cause intermods with another transmitter. You've got this broadband energy that could be creating intermods that exist all across the spectrum with that frequency that you're trying to use.
Great. Okay, is setting the exclusion threshold above 85 dB really likely to cause more problems with interference?
That's a great question, and I think that really depends on your noise floor. So for the scan that I'm showing here, you can see that my noise floor is actually really close to negative 100 dBm, and it doesn't get much higher than that. I do have a few TV channels and some transmitter signals that are out there, but putting your exclusion threshold higher or being a little bit more aggressive with the spectrum that you'd like to use, it won't necessarily negatively impact your coordination. It really depends on your tolerance for this gap between that exclusion threshold and your noise floor, and how likely you think it is to rise over time.
Great. Okay, how about using zones as temporal slots for multiband festival type situations?
Oh, that's a great question. I have seen people do that, and I haven't done it too much for myself, but it is quite possible. So in the same sort of way that we're talking about distance or obstructions affecting our zones here, you could also use that for temporal slots, such as, let's say that I've got all of these are named by band. So I've got band 1, and I won't type all of these, but band 2, and so on and so forth. What you might expect, and I'll just go ahead and ignore everything here on the default since we won't be using that. But for band 1 and band 2, it might be that you need to coordinate frequencies for band 1, and while they're on stage, coordinate frequencies for band 2. You might even want to have them power up their transmitters or their portable receivers just so they can get started and be ready to run out on stage immediately. In which case, you might want a pretty stringent relationship between those. So in this intersection between band 1 in this column and band 2 on this row, you could just as easily consider both channel-to-channel spacing and intermod spacing in order for that to be coordinated appropriately and to make sure that you're not stepping on yourself. In the same way, if you've got band 3 that's coming up after band 2, we can look at that relationship and make that stringent. So what we'll notice is a pattern here is that for band 3 and band 4, for band 4 and band 5 and band 6, you'll see all along this trajectory here that you've got this very stringent relationship between the zones. Whereas band 1 and band 3 might not ever be on the stage at the same time or playing at the same time, in which case you can disassociate those two zones from one another. And again, the trend follows, so band 2 and band 4 are probably not playing together, band 3 and band 5, band 4 and band 6. And in this way, you can really coordinate for temporal slots as opposed to physical spaces.
Awesome. All right. Can you name devices in the frequency coordination tab?
Naming devices in the frequency coordination tab is not possible, and this is kind of this is because the inventory and the frequency coordination space have been decoupled in a way that allows you to iterate on your coordination without affecting your inventory. So you'll notice that even though I had all of these frequencies that I brought in from my inventory, they were virtual devices and they still don't have a frequency yet. And so when I brought them into this coordination workspace, they still didn't have a frequency until I coordinated them. It's really on the roundabout when you go to assign and deploy the frequencies that you've calculated back into the inventory that you can associate a name to them. However, you can name all of your devices up front. For example, selecting all of these, changing the name to channel, and we can auto-enumerate that from 001 and rename the channel this way. And so if I were to bring back in those frequencies, for example, just tossing away this coordination for a moment and bringing in my frequencies again, you'll notice that this repopulates within the source column with the channel name that you've designated in the inventory.
Great. Does Wireless Workbench work on both Windows and Mac?
It does, yeah.
All right. On QLXD, can you scan on the receiver and lock in their frequency, or do you need to turn on the transmitter one at a time after each scan?
I wonder if your question is related to the procedure that I mentioned earlier in the presentation, in which for your testing and setup, I would recommend turning on all your receivers and a single transmitter. If you're just doing a general scan and want to know what your RF environment looks like, I'd recommend just turning off all transmitters. That includes your IEMs or IFB transmitters, as well as your microphone transmitters, running a scan, and that will show you what it looks like without any of your frequencies in the spectrum. However, if you are trying to go through this testing setup, then I would recommend just one transmitter at a time, and then once you're moving on to the second zone or the third zone or any zone thereafter, turning on the transmitter for the zone in question.
Great. Next question, actually, I'm going to take. Hi, do I get a certificate for this training? This specific webinar does not have certification. However, we did just recently launch a new RF certification training program. And if you go to our website at Shure.com under the training tab, you can find links to our new SAI RF certification. So great question and very timely. We do have that available. Just go to Shure.com and check the SAI Shure Audio Institute section of the webpage. Okay, next question. What is the maximum recommended overlap between two groups like you have shown?
The maximum recommended overlap. So feel free to type in the comments section if I don't understand your question correctly. But for this inclusion group, this is really up to your own purview. If you'd like to have them overlap entirely, then you wouldn't use inclusion groups at all. Whereas if you just wanted to make sure that you're getting as many frequencies as possible for a system, which is what I was doing since I was coordinating this off the cuff, I just made this overlap of 12 megahertz here. But for zones, we kind of covered this a little bit in the presentation, that it really depends on the RF energy that you're measuring in the other space. So if I turn on a transmitter in zone A and I measure it in zone B, if that signal that I have for my transmitter in zone A is below negative 85 dBm, you might as well consider it in the noise floor and not an issue. So that would be a separate zone. Whereas if it's above negative 85 dBm but below negative 70 dBm, this is where you would consider the relationship between them in that sort of default state, where you respect the channel-to-channel spacing but ignore the channel-to-intermod spacing. And then if it's above negative 70 dBm, you might as well consider them the same zone, because that's a pretty hot signal.
Great. How much dB of separation would you recommend leaving between the exclusion threshold and the overall noise floor?
It's a great question, too. I have found myself going all over the place, and for things like this scan here, where my noise floor is pretty uniform across the spectrum, oftentimes I'll find myself shoving this way down into the noise floor. And so for something like this, I could put it at like negative 90 and still feel pretty comfortable. I'd also even feel pretty comfortable with negative 95, because really there's not excessive energy there. If you really, really want to get dialed into all of the frequencies that might happen, like what I'm looking at here and what I'm hovering over, seem to be a couple different, and I'll snap this to the plot here. What I'm looking at here and here at 487 seems to be some sort of intermod signal that could be generated from one of these TV stations and some other transmitter that I've got going on. But really, I think it's up to your own tolerance. What I'll find sometimes in scans in certain environments, especially where I might be close to an LED wall, for example, is that this broadband energy might be really high in the lower frequencies and sort of taper off, in which case I might want to go with a little bit more aggressive to start with, just to see how many frequencies I can get, and then start backing it down to be more conservative if necessary.
Great. Okay, next person says, we are located a half-mile from an international airport. Are there frequencies normally in use at airports that conflict with Shure wireless mics?
It's an interesting question. I think in most places you'll find that the UHF spectrum, because it's an unlicensed band, does have frequencies in use kind of all over the place. And so that could be something as simple as like a karaoke mic that's being used at the bar inside of the airport, for example. But with respect to the actual aviation administration, I don't think that they're using frequencies on planes or for ground communication that interrupts the UHF band. There are several VHF transmissions that happen though for intercoms and that sort of thing, as well as in the 900 megahertz band, both the ISM band and the STL band. From 900 to, I believe it's 960 these days. There are frequencies in use there. So they can interrupt, and one of the best things that you can do is to scan in advance. Also for certain agencies like the Aviation Administration, at least from what I've gathered here in Chicago when I've gone to O'Hare, I've just been polite when I go ask and say, hey, are you guys using any frequencies? Just want to coordinate for a show that I'm doing down the street. And usually they'll put me in touch with the AV or IT person who's got some of that information. Not saying that everybody is that nice, but doesn't hurt to ask, right?
Right. All right. Next question says, can we have contact info for our next project for clarification or questions? Yes, you can always get in contact with our applications engineers at support@shure.com. If you're located in the U.S., you can reach them via phone at 1-800-518-0446. That 800 518-0446 or support@shure.com. The people on that team are great, and they can talk you through any wireless workbench and frequency coordination questions you have. They're fantastic. Okay, let's see. Next question. They're just really pouring in now.
All right.
Okay, are there any limitations or problems in adding other manufacturers into different zones, such as Sennheiser G3 IEMs?
Great question. There is no issue with it other than it's another frequency. So we do support several other manufacturers and their systems in here. So if I go to Sennheiser, I believe we've got the G3 in here. Right, I can find an EM or an EW100 G3 in the A band. It's got its own spacing and filtering parameters here. And so it's treated like any other device. It's just got its own spacing parameters. So yeah, feel free to use those in your zones as you see fit.
Great. Okay, could you explain why sometimes I have intermodulation issues coordinating Shure systems with other systems like Sennheiser in Wireless Workbench?
A very similar question. The intermods will happen on just about every system really. These are all wireless microphone systems, especially because it is wireless, is technically a nonlinear system. And so what goes in is not exactly what comes out. And that's the nature of intermods. So if you've got two signals operating close to one another, they technically are going to make intermods, especially as the proximity of those transmitters or the proximity of those receivers or the transmitters to the receivers increases. So it's not really a Shure and Sennheiser sort of thing. It's just a wireless microphone phenomenon.
Great. Okay, does Wireless Workbench 6 take high-density mode into account when calculating frequencies for ULXD and or Axient digital systems?
It sure does. I'm going to go ahead and add them over here on the right sidebar just to show that this workflow also is supported, but I can add some Axient digital in a given band, and then you'll notice that once I choose the band, this RF profile parameter shows up, and so you can add HD frequencies, and so we treat those differently. A quick way to show that is I'm in band 1 right now. I've got my standard transmission mode and I've got my high density transmission mode. If I go over to the compatibility tab, this is just a quick view into my equipment profile spacings based on which compatibility level I'm using. And so if I were to switch back and forward between standard and high density, you can see that really the only parameter that changes with respect to channel to intermod spacing is the two transmitter third order spacing. I can also go into the equipment profile and see the same thing. If I were to go to the G57, I've got my transmission mode here as standard or HD. And this is where you can see the full spacing parameters change. So it goes from a spacing of 350 or channel to channel spacing of 350 on standard transmission to a spacing of 125 kilohertz in HD. So yeah, we do account for both standard and high density transmission modes in Wireless Workbench.
Great. Okay, how about having separate RF environments or scans in different zones? That'd be a great feature to avoid local RF anomalies between stages or zones.
That is a great recommendation. I'll have to look into that. I think that's something we can do.
Awesome. And that is something you should know. I mean, we're on version 6.13 of Wireless Workbench. So as you can tell, we're always working to advance it and improve it and make adjustments. So that doesn't fall on deaf ears.
Definitely not. Thanks very much.
All right. Next question. What should we scan first, IEMs or mics?
Great question. So there are a couple different ways that you can scan for these systems. I think if you're just populating your scan data, any order is perfectly fine. When you're calculating, though, something to note in Wireless Workbench is that when we add frequencies to this space here that we call the coordination workspace, the order in which we put the devices is actually pretty relevant. What we typically do is we put those systems that have much wider spacing, or let's say they're less frequency agile. They don't have as many frequencies. So this could be because they have a narrower tuning bandwidth. It could be because they have wider spacing because they're older technology. Whatever it is, we put those closer to the top, and those are always the ones that get given their frequencies first, and then we work our way back down to the more frequency agile systems and those with wider tuning bandwidths. So you can actually see the coordination order of those systems if you go into the coordination preferences. There are two ways to get to that. You can just go to the application preferences, and then there's a tab for it, coordination and coordination order. Alternatively, in the coordination workspace, there's this gear icon that'll take you directly to the coordination preferences. And this is where we show by series and band and RF profile the order in which we would calculate each of these systems. So again, to your question, it doesn't really matter when you're scanning which ones that you do first. You just really want to know which ones you want to calculate first. And so this order is also mutable, so I can move things around if I need to. And what you'll notice is that this icon here changes color when you've modified your coordination order. I can just click that button and reset it back to the default. If you're going through the testing setup that we talked about in the presentation here, I would say one of the most important things to check would be your highest RF output power. So oftentimes that will be your IEMs, and so if you do have in-ear monitor systems in each one of your zones, I'd recommend using those transmitters because they typically have a higher RF output power than your microphones, and so they'll give you a better indication of what sort of relationship you want to configure between those zones.
Great. All right. How can I assign a complete coordination made offline in Workbench at home to the systems once I'm at work and connect all the receivers online?
Excellent question. We have a merge function in the inventory. So this is, you guys are asking such great questions. Remember how I mentioned that you can add frequencies directly in the coordination workspace. So again, I'm just going to throw this away so I can show you what it looks like by default. If I were to add this Shure Axient Digital G57 high density into zone 3, it doesn't actually make its way back over to the inventory. It's sort of just a little nugget of information that hangs out in the coordination workspace. And so if you're planning to connect to your systems at some point, if you have the opportunity, you can even connect to them next time you're at work prior to your coordination, in which case they'll be automatically discovered in the inventory. And then once you disconnect, they'll just look like they're in this offline state here where this gray bar, instead of being green when they're online, it's just gray to denote that they're offline. That's the quickest way that once you perform a coordination by bringing in your frequencies into the coordination workspace, that when you deploy them, they end up going back to the inventory to the devices from which they came. And when you network back to your equipment, you'll get a conflict settings dialog that pops up, and it'll basically say the equipment that you have networked doesn't match the same frequency settings that you have in your inventory. Which of these settings would you like to take? And so that's a very, very quick way that you can sort of just get up and running with the devices that you already had, perform a coordination offline, and push them right back to the devices again. And so just how I created all of these devices from the Add New Device dialog, it works pretty much the same way, except when you network to those devices back in your office, they won't automatically come up with the conflict settings, but what you can do is take a given channel or a given device and drag it on top of one of those online devices, and that same conflict settings dialog will come up and prompt you to choose which setting you'd like to take.
Great. All right. How would you use Wireless Workbench in the pre-sales design phase of RF coordination?
Good question. Something that I typically do when I'm trying to figure out how many frequencies I can get in a given space is I might take, I'll just go back to my default zone here. If I wanted to spec Axient Digital, for example, say this comes on the rider, but I'm also vacillating between Axient Digital and some other system, I might just add a single frequency, a primary frequency, for example, or I can add 50 of them or 100 of them, doesn't really matter. But we have a setting in the coordination preferences that lets you automatically calculate backup frequencies. And this is a very, very quick way, a handy way, where it's going to find that first frequency that you asked for, but then it's just going to fill up the rest of the available spectrum that it can with as many frequencies as you can for Axient Digital. So I can just hit the calculate button and it'll chug away, and I'm not going to let this sit here and chug forever, but basically, given my scan, given all the constraints that I have here, it basically says I can get 256 channels of Axient Digital on air at the same time. Now, mind you, this is the high density one, so if we were to repeat this with a standard mode, for example, and add that one frequency and automatically calculate backups, it says that I can get 79, but I'm not going to let it keep chugging. So I can get around 79 frequencies on air at the same time. And I think this is a very good way during the planning phase to figure out, all right, well, this is sort of the max amount of frequencies that I can get. The same thing can be done if you're trying to calculate for both microphone transmitters and IEM transmitters. I can go add a PSM system, grab a band, add it to it, and so if I get rid of my Axient Digital, I can do the same thing. But if I wanted to find out how many PSM can I get, assuming I needed all 79 of those Axient Digital signals, I can calculate. Oops, I forgot to lock. So this is just a different scenario. This is basically saying, all right, well, I've got two systems. I want to see as many frequencies as I can get for both of them. Well, turns out I can get 34 Axient Digital and 17 PSM, again, stopping the calculation early. If I wanted to repeat what I originally intended to do, right, just grab as many Axient Digital as I can. We'll stop at 79. What I can do is I can open up this and I can lock all of my compatible frequencies. And so if I collapse this again and now ask for my PSM, I can calculate again and it'll tell me how many frequencies I can get on top of that.
Exciting. All right. How aggressive would you make your noise floor when dealing with IEM and wireless mics?
Again, it depends on sort of what the noise floor of the scan is that I'm seeing. Again, using this as an example, my noise floor is so low, and I think I did this, if I'm not mistaken, in a pretty isolated environment. Most of my transmitters were off except for some of these sort of rogue transmitters. I'm really just running into TV channels. And so what I like to do is I like to hover somewhere between 8 and 15 dBm above my noise floor, and that gives me some sort of tolerance that I have between it to play with it. Usually what I'll do is I'll try and start as stringent as possible because this is what creates all of those additional exclusions for me. So I turned off that filter just so you couldn't see all the mess that's in there. But if I were to move my noise floor, my exclusion threshold way down, you'll notice that all of these exclusions pop up. All of these purple areas are places where the calculator will not put frequencies. But if I want to be more aggressive with it, I can say, yeah, feel free to put all those frequencies anywhere. But that means that in certain circumstances, like here on these TV channels, TV23 and TV25, that now the calculator doesn't know about it, and it might try and put frequencies there. So you'll want to assess your noise floor sort of across the entire spectrum where each of your bands are laying, and then sort of just take an average across the spectrum.
Nice. Okay. What impact does changing front-end filter between fixed and tracking have in equipment profiles?
So the tracking filters and the fixed filters here, let me pull it up. The front-end filters for wireless systems, if you're using tracking, for example, this assumes that you've got a better filter on the front end, so those equipment profiles basically allow it to move wherever that frequency is going to be. Whereas if you have fixed filters, it's basically saying that you don't have quite the same filter selectivity. So you'll notice that if we jump back and forward between these, it's basically saying that if I've got tracking filtering, I'm looking at a narrower filter here. And so this is very important when you're considering this spacing. It's basically saying that on the front end, there are other signals that can get in and impact my frequency. So if you're dealing with an older analog system that probably only has fixed frequencies, or if you're using a more modern system that has filtered ones, all of those are built into the profiles here, but you can also make custom profiles So yeah, it's really just adjusting how other frequencies impact the filter selectivity and channel spacing of your coordination.
Great. Okay. Say you have Axient, ULXD, and QLXD all possibly in the same zone, possibly in a corporate or conference situation. Which would you suggest using to do an initial RF scan?
A great question, and it really depends on your workflow and how quickly you want to move. If you've got Axient, ULXD, and QLXD, you're really going from widest bandwidth down to narrowest bandwidth, just in terms of the frequencies that it can tune to. And so if you just want a pretty high-level picture of your spectrum, I would use the wideband system, and that would be the Axient Digital in this case. Especially if those bands overlap with one another, then you'll be getting a pretty good view of your spectrum there. However, if you have systems that don't overlap, where their frequency bands don't overlap, then you'll want to use as many receivers as is necessary in order to get the full picture of your spectrum. There would also be some logic in taking a scan with each one of them just to see the different noise floors. So each one of those systems, the ULXD and QLXD use a common radio. The Axient Digital system uses an entirely different radio, and so if you were to scan with each of them separately, you might notice like a couple dBm difference in their noise floors, and so that's just a good way to be very certain about what it is that particular radio is seeing.
Great. Okay, next question. I'm working on a cruise ship, and thus interfering frequencies change along the route. What would be the best way to scan and coordinate frequencies? Is it possible to do multiple scans and overlay them for the best performance along the route?
Ooh, great question. I have never tried that, but that would be such a good one. If you've got multiple scans in your coordination workspace, and I'll just pull out a few here. Just grab any one at random. Let's go with Mexico City because I think that looks different. Mm-hmm. I'll color this separately as well so we can see it. Okay. When you're looking at this, any scan files that are checked and visible in the frequency plot are technically being accounted for, and it's really the peak of all scans that the calculator is working against as part of the exclusion. And so just to summarize that, I can click the peak hold scan summary here, which doesn't further affect the coordination. It's just a very quick way to see what's the peak of all the scans that I'm working with. So that is definitely something that you could do. You could coordinate whether it is distance-based or time-based along your route to say that, yeah, I know that in this space I typically get more interference on these frequencies versus this space versus that space. And so if you were to take a scan at each one of those locations, you can basically check all of them and then save that as a peak hold. And that will then be a scan that you can bring back in here so that you don't have to have a whole mess of all of those different scans that you had. And that would be a very easy way to just say, all right, here's the peak of RF energy that's happening along the entire route. Now, the downside of doing that means that if across your entire route all of your spectrum is taken up, it's all above your exclusion threshold, then you'll have no frequencies or no spectrum to work with. And so an alternative way to do it is to maybe coordinate frequencies by zone, but now considering them in time as opposed to distance. And then for each one of these scans, this might be my scan in location 1. I'd coordinate frequencies there, and then I'd do another scan in location 2 and coordinate frequencies there, and then save these as backup frequencies. So they end up going to a backup frequency list here, and you can use that so that if interference comes along, you can quickly move to a backup frequency. But your idea of taking the peak spectrum across all of those different locations would also work too, provided that not all of your RF spectrum is taken up.
Wow, that would be a fascinating thing to dig into for sure.
Yeah, that's
wow.
really cool.
All right, guys. Unfortunately, we are out of time and we didn't get to all of the questions. Many apologies if we did not get to your question. I will forward these questions on to Corey and he can maybe answer those separately for you at a future time. We want to thank you so much for joining us today. As I mentioned, this webinar will be available for on-demand viewing in about a week or so at shure.com/webinars. We want to thank you so much for joining us today and asking so many great questions. We hope you learned a little something. I know I sure did. And we will see you on the next one. Bye, everybody.